The point I emphasized in my interview with Peter Doocy on the Sunday briefing of Fox News yesterday is a simple but profound reminder. The true foundation of science is humility, not the arrogance that sometimes grows from expertise. Humility is the willingness to question long-held assumptions, to confront the unknown without imposing familiar interpretations, and to allow new evidence to reshape our understanding of reality. Expertise, on the other hand, can become a trap when it restricts imagination to what has been previously cataloged or observed. I used the example of Comet experts and their immediate reaction to the discovery of 3 Ice/Atlas on July 1, 2025. Within hours of detection, before enough data was collected to genuinely characterize the object, many experts rushed to label it as a familiar water-rich comet, simply because this classification matched what they had seen countless times in their careers. Their response resembled the behavior of artificial intelligence systems, predictable, constrained, and heavily influenced by the training data fed into them. For decades, cometary science has been shaped by observations of icy rocks from within the solar system. Naturally, when a new object appears, the default assumption is to match it to past experience. But this habit is exactly what prevents progress, especially at a moment when the universe may be offering us evidence that does not fit neatly into old categories. The training set of Comet experts includes icy bodies, sublimating volatiles, and dusty trails, the classic signature of comets long studied in our cosmic neighborhood. But humanity has changed its cosmic environment. We have launched thousands of technological objects into space. Satellites, upper-stage rockets, spacecraft, probes, and even one whimsical red Tesla Roadster car that Elon Musk sent into space on the first Falcon Heavy test flight in 2018. These objects now coexist with natural space rocks, orbiting the sun or traveling outward into interstellar space. Therefore, when astronomers observe an unfamiliar object, it is no longer sufficient to assume it must be a natural rock or a comet just because that is what past generations of astronomers saw. We must update our scientific training data set to include the fact that technological artifacts, some of human origin and potentially some of non-human origin, now exist in interplanetary and possibly even interstellar space. A recent example perfectly illustrates why this adjustment is essential. On January 2, 2025, the Minor Planet Center, which operates under the International Astronomical Union and is responsible for cataloging newly discovered objects, announced the detection of what appeared to be a near-Earth asteroid. At first glance, its trajectory looked like that of a typical small object orbiting near Earth. But a day later, officials recognized something unusual. The object's path was not random. It matched almost exactly the predicted orbit of the Tesla Roadster launched by SpaceX in 2018. Once they realized this, they immediately removed the object from the asteroid catalog. It was not a rock at all. It was not a relic of solar system formation or an icy body passing by the Earth. It was a human-made technological object mistakenly classified as a natural one simply because the automated detection system and the humans interpreting it did not initially consider the possibility that a car could be orbiting the sun. This is a perfect demonstration that misclassification can occur when our expectations blind us to alternative explanations. And if this mistake happened with an object built and launched by humans only a few years earlier, how much easier would it be to misinterpret an object that originated far beyond Earth, created by civilizations that may have existed millions or billions of years before us? The example of Elon Musk's Roadster also raises an interesting philosophical question. Humanity sometimes thinks of its achievements as unmatched, especially in our own era when private companies can launch rockets, land boosters, and send vehicles into solar orbit. But there are around 100 billion stars in the Milky Way galaxy alone, and roughly 10 billion of them likely host Earth-sized planets in their habitable zones. On each of those planets, there may have been opportunities for life to arise, evolve, develop intelligence, and eventually create technologies far more advanced than anything humans have built. To imagine that humans are the greatest spacefaring engineers the Milky Way has ever produced is statistically unreasonable. Even if technological civilizations are rare, the sheer number of possible worlds means that advanced spacefaring societies could easily have emerged long before humans existed. Some stars in our galaxy are billions of years older than the Sun. Any civilization that arose early in their history could have had more than enough time to develop technologies capable of traveling between stars. Furthermore, the vast timescales of galactic history make interstellar travel more feasible than most people realize. Imagine that an early technological civilization launched probes similar to our Voyager spacecraft. Voyager 1 and Voyager 2, built in the 1970s, are now traveling through interstellar space. At their current speeds, they could cross the entire diameter of the Milky Way, about 100,000 light-years, in roughly a billion years. A billion years may seem unimaginably long on a human scale, but on a cosmic scale, it is entirely reasonable. Many star systems are older than the Sun by several billions of years. That means that any probes, spacecraft, or expelled technologies from ancient civilizations had more than enough time to drift across the galaxy and potentially pass near our solar system. If our own primitive 1970s-era technology can accomplish this, then more advanced civilizations, if they exist, could have built machines that travel faster, last longer, or navigate intentionally to points of interest. This brings us back to the key question. If a technological object from another star system entered our solar system, would Comet experts recognize it as artificial? The truth is that if their training set includes only natural objects, then they might incorrectly classify such an artifact as a comet or asteroid, just as they did with the Roadster at first. A sufficiently weathered, eroded, or long-traveled interstellar artifact might not look like any technology familiar to us. Its surface could be pitted, darkened, or covered in layers of cosmic dust collected over millions of years. Its shape might not resemble any Earth-based spacecraft. It might not generate radio signals, heat emissions, or reflective coatings recognizable to Earth telescopes. In short, it might appear deceptively natural. Yet beneath that misleading surface, it could still be technological. This possibility is not science fiction. It is a logical extrapolation from the simple facts. Advanced civilizations may exist. They may launch artifacts. Such artifacts can travel vast distances over geological timescales, and objects entering our solar system are routinely classified based on assumptions that may no longer hold. The scientific community must adapt to this reality. To insist that every new interstellar object must be a familiar comet because previous ones were is equivalent to assuming that every unexpected sound in the forest must be a squirrel simply because most past sounds were squirrels. Such reasoning is safe, but it is also blind. Science progresses when we allow unexpected observations to challenge our frameworks. The discovery of interstellar objects like 1I/Oumuamua and 2I/Borisov already forced astronomers to acknowledge that visitors from outside the solar system exist. If humanity is now part of a galactic ecosystem containing both natural and technological objects, our classification systems must evolve. We must be willing to examine anomalies with fresh eyes, unburdened by old assumptions. We must treat outliers not as errors to be dismissed, but as opportunities for deeper understanding. The universe may be sending us messages through the form of these objects, not literal messages, but clues about the processes, civilizations, and histories that shaped the Milky Way long before humans existed. To interpret those clues correctly, we need humility, curiosity, and the courage to expand our scientific imagination beyond the limits of past experience.